Then thank you very much for staying that long, especially being the last presentation today. Don't get irritated with my sales title. I'm not going to try to sell you anything today. I promise. And if I don't hold this promise, you can just go to booth 422 and hold me accountable for that. What I'm trying to do today is to show you probably a couple of good solutions for maybe problems you have, maybe some problems you identify, maybe some others you haven't. And I can give you some idea of what's going to happen today. I expect a lot of questions. I'm going to try to be brief, so to allow questions. And the first 4 questions are going to get a present from me. So if you fancy nice socks with DNA molecules and bacteria and everything, then try to make a question. All right. So in our view, and that's only our view, and I'm trying to be provocative here, to be honest, there's a gap, or there's many gaps in the pharmaceutical industry, in the pharmaceutical processing. Especially there's, in our view, I need to point out, there's 2 gaps. One gap could be between upstream and fill and finish. And the other one could be between upstream and downstream. When it comes to the gap between upstream and downstream, that's typically in processes where you have a huge amount of intermediates that you want to freeze, for example. Inclusion bodies is a good example, right? You normally have a big amount of inclusion bodies, and typically you actually freeze these inclusion bodies before you continue with the downstream process. Between downstream and fill and finish is probably more evident. There's a lot of very nice solutions in the market, like the one from Lonza, where I worked before, where you try to actually standardize and offer a one-stop shop in having drug substance and drug product production on one site. However, this is not always the case. And there's good reasons why sometimes it's not the case. Sometimes you have a huge amount of drug substance and you want to distribute this drug substance within different parts of the world and then do some fill and finish closer to your customer. And some of the COVID vaccines we recently seen are a good example of this kind of supply chain. Although it's sometimes a good idea to have a centralized one-stop shop, sometimes it's also a good idea to do the opposite. And therefore, in our view, there's a gap between downstream and fill and finish. And that's where we come to play. There's a lot of different solutions we offer to our customers to actually fill these gaps, to help you to cope with these kind of situations. And I'm going to present you 3 very short case studies to give you a bit of a flavor of what are the kind of things we do with our customers in order to help them to fill these gaps. So the first case is managing fluids, right? So we all know all the Annex 1 requirements we have. We all know that managing sterile products can be challenging sometimes, and we all know that that can be also expensive and resource intensive on top. However, there's other ways you can do that. You can use some kind of technologies like this one, and we're proud to be one of the market leaders in these kind of solutions, where you can do aseptic filling in a closed system in a more simple way. So there's not always the need to use an isolator for that. Right? You can have a machine like this one, very small, I can share the slides with you if you like. So feel free to take as many pictures as you want, but if some people want to have the slides, feel free to reach out to us, booth 422, and we can share the slides. So there's very small machines you can use for filling very small amounts of material in bags, for example. There's also big machines for filling very small amount of material in bags with a very high accuracy. And there's a whole range of different fillers that you can use to fill different amounts of material to cover the gap between downstream and fill and finish, or to use the final product, to use it for fill a final product in a bag, for example, right? So the advantages here are very much resumed here. It is universal. In our case, you can use whatever bags you want. We're not going to lock you in to use a specific bag, as some of our competitors do, to be honest. You can scale and transfer between different equipment with highly reproducible results. We're completely agnostic when it comes to the material, not only the bags, but also connectors, tubing, etc. We can build the manifold using exactly the kind of components you are now using in a manual fill process, for example. And we tend to believe that we're using friendly. But let's go back to the science content. Too much sales already. I'm not sure I'm going to hold my promise. So this is a real study where a customer reached out to us saying, listen, I need to fill bags or I need to fill bottles for a drug substance in an isolator. And I don't like isolators, he said. I said, well, thank you. I don't like isolators either, although sometimes it's necessary to use one. And then we actually started a project, and we compare. So he told me, please help me to sell the idea of using a different technology instead of an isolator. I say, yeah, perfect. As long as I can use the slides for conference, I will do it. And there you go. So, for example, the background area you need for an isolator is higher than the one you need for a closed system. The type of utilities you need are very stringent. So you need hydrogen peroxide vapor, you need different power, you need compressor, everything. Our machines are plug and play. You can put one of these machines in this room and do aseptic filling here. And I'm not kidding. There's customers who do aseptic filling in black areas, right? You also have a very manual process using isolator. It's not easy to actually automate an isolator process. In our case, everything is automated. You can even generate batch records, manage users, as well as export all the different areas, different data you generate, and increase traceability. Sometimes you even need to reinforce the floor of your facility if you're not on the ground floor to put an isolator because it's very heavy equipment. And you normally need more operators to actually carry on the same processes. In this particular case, it's a low-scale process. This is a process managing roughly 50 to 100 liters of drug substance, right? And our estimation was that you can carry on the whole process using only one operator. And I'm not going to give you all the details because I want to have a conversation with you about it. So just feel free to reach out to me afterwards, and I can tell you much more. But there's another slide on that, which is time. You need roughly 2-3 hours to operate a system like the isolator, and you roughly need 1/3 of the time, roughly 1 hour in our case. The investment is also much higher. I can promise you that you can actually have roughly 25% savings by using a machine like ours, right? And then the risks are higher because, as you know, if you have cross-contamination using isolators, you might probably need to discharge the whole batch. In our case, sometimes you've been really skeptic. Thank you. Feel free to ask questions. Sometimes you can skip only one bag, and then after that, you're safe. But not everything that shines is gold. There's one limitation here that I want to share with you. For using these kind of systems, at the moment, you are limited to using bottles and bags. You cannot use vials. If you want to use vials, reach out to us, and we are very happy to engage in a co-development to develop a machine like an automated closed system for filling vials. But we don't have it yet. We're working on that. So the second case study that I'm going to present today is freezing. So we also offer a wide variety of freezers in different scales. And some of you in the room are already using our freezers. Thank you for coming, by the way. And developing a process in order to control, freeze drug substance in a more reproducible way, in a more product-friendly way. And I know, for example, we have a couple of them at Lonza, especially in Visp. So, some of you will say, what's wrong with a blast freezer? Well, there's nothing wrong with it, but there's much better of use. There are high advantages of that, right? So let me show you this slide. That's a conventional freezer compared to an advanced plate freezer. I don't think I need to tell you much, but you see the differences in color here. So there's a dyed drug substance we froze using different technologies. You see all these differences in concentration you have in the bag. So what happens here is you're going to have different concentrations across the bag of salts. You're going to have different concentrations of drug substance within the bag. So it's not going to be an homogeneous process. So you're basically not treating your nice product well. Some products are so nice that they actually okay with that. But there's better ways to treat your product. You might probably also have some pH differences within a bag. So stop treating your very kind product so badly and use plate freezers, please. Let me show you something. When you use these kind of plate freezers, you basically what it happens is that you actually freeze from bottom to top and from top to bottom, and these two fronts meet in the middle, right? And you not only control the freezing more accurately, but you also do it faster. And the beauty of these kind of systems we have is that you can also do the same with the thawing and also save time on the thawing side. And I can show you a video offline where you see how this freezing procedure works in reality. There's also some data here, and please, if you find a better way to present this data, let me know, because I'm not so happy with this data. But basically what we did here was to actually freeze a big bag using both technologies, take some samples, drilling out some holes in the bag, and then measure the concentration range of the drug substance in different points of the bag. And as you can see here, the conventional freezer has a huge variability when it comes to the regular, to the more advanced plate freezing technologies. And that actually matches very well the first picture I show you when I show you all these differences in color between the conventional and the advanced plate freezer. There's much more to say here, so feel free to reach out to me. My goal today is to make you curious, to provoke you maybe, and engage with you in a conversation about if that will be something that could eventually be beneficial for you. But there's another third business case that I want to present you, or a case study, which is the fact of using bags. I know there's still a lot of resistance to change from bottles to bags in some cases, because bags, let's be honest, they break. But there's no reason, don't blame the bag on that, just protect the bag, please. So the bag itself is a very bad packaging material to be transported from one place to another. And as we've seen in the first slide, there's a lot of transportation, a lot of handling you need to use to cover these gaps. So if you freeze a bag like this one at temperatures roughly -60 to -80, this thing is like glass, as you know, better than I do. They break. And you only actually find out that it breaks when you are ready to produce and you thaw the bag. So what we're producing here, what we're offering here, is a very simple secondary packaging material, the raw shell, which is in use in some of your facilities as well, to actually prevent this breakage. It's a very simple construct where you have two stainless steel lids up and down, and you have a thermoplastic material, a foam, surrounding the bag, and the whole construction is made specifically for the bag of your choice. It's not a standard one. Each type of bag has a different type of shell. And we are so flexible here that we offer shells for all the big manufacturers in the market, although we also sell bags, to be honest. But you can take the bag of your choice, even if it is from a competitor, and then protect your bag with this secondary material we call the raw shell. Because we understand that we are not the only suppliers of bags in the market, and we understand you probably have a lot of data using bags from other suppliers, and we don't want to push you to actually change your bag. We want to help you. We don't want to make your life more difficult. So that's something you can use. And there's also a bunch of extra benefits on using these shells, especially in combination with the plate freezers, because then the freezing process and the heat exchange for freezing and thawing is going to be more effective. So you're actually basically having a very nice side effect on top of protection, which is even more control of the freezing and thawing procedure. And these are real data from a customer of ours that was using naked bags in the past and then changed to our bags. And they were losing roughly 600,000 euros a year, dollars, sorry, in bag breakages. And these are direct losses. So we're only talking about the losses of material when the bags broke. We're not talking about the losses of sales of final product, which might be probably even higher. They didn't like to tell us that. But the losses of material were 600,000, right? So it makes a lot of sense to invest a bit of money in protecting your bags, because in the end you pay off. And if you wish, I can show you some data that tells you that using these raw shells will pay off roughly after 3 months of usage, depending on the volumes you have. So that's also something to consider. I'm aware of the fact that all of the people here in the room are manufacturers, and probably you are more worried about things like glycosylation, we heard, or, I don't know, protein structure, type of bioreactor, efficiencies, and so on. But please don't forget these kind of things. This is a small piece of the pie you manage directly. I'm aware of that. But this is a very important one. There's a lot of efficiencies to gain here. There's a lot of headaches that you can avoid by using our technologies, although it's a small piece of the pie. But it's also low-hanging fruit. You don't need to make too many changes to actually have a lot of benefits. So my goal here is to make you aware that although you're not thinking about these things every day because you have probably bigger problems to solve, just dedicate some time to think about these things, because it's probably a good idea. That's all I have to say, but I will be happy to answer your questions. Thank you very much. Don't forget the socks. You think like you were thinking about different things. So you were also very interested. Can you share your thoughts with us? Please go ahead. No? Okay. So I want to ask you a question.
I think it's just great. It's just
yeah.
simple.
Yes, you're right.
Obviously, something
impatient.
that is really simple. I checked your company details in the back, and the scale you're going through is really impressive. So congratulations on that. And I disagree with you that you said this is not a sales event. I think it was a great sales event, actually. So you did a great job there. So congratulations on that. Yeah. Simple ideas are often really good to follow. Yeah.
I only have a question on that. What's your shoe size, please?
46.
There you go. The first one is gone.
Thank you.
Thank you very much.
Thank you. It was an interesting presentation. The raw shells, is it the purpose of that is for single use, or can we use it multiple times?
We have both. We have both variations of the shell. The first generation of our shells was the single-use one. And depending on the case, it makes a lot of sense for you to either use single-use or multi-use. Let me go back to the raw shell. So when you use multi-use shells, you still need to change the foam in direct contact with the bag every time you use it. The reason for that, there are two reasons for that, actually. The first one is when you thaw the drug product, or the drug substance, sorry, the foam absorbs some humidity. And you don't want to have a humid foam reintegrated in your production plant because of obvious reasons, basically contamination, right? So that's the only part that cannot be multi-use. But we can sell you only the foam, and it's a fraction of the price of the full shell. So you just change the foam and reuse the shell. The multi-use shell looks a bit different, but it's possible, no worries. In some cases, if you ship the drug substance very far away, it doesn't make too much sense to, let's say you produce in Europe a drug product and you produce drug substance in Asia. We have a customer that does it. It's not uncommon. There's one CMO in Asia producing the drug substance and then shipping all the way across the different continents to produce drug product in Europe, not far away from here. So in that case, they don't reuse the shells. Just send it to us and we recycle for them.
Thank you. I have a second question. Is there a possibility to attach a temperature monitor to the raw shell?
Yes, there is. You can have trackers, not only tracking temperature, you can have GPS coordinates, so you always know where your product is. You can have G-forces measured, so if somebody drops the shell in the process of drops a container with a lot of shells in it, you will always know all this data. No problem.
Thank you.
And we also have customers using standard shell bags, but using a very complicated system of tubings and like samples and everything on top. It looks like a bit like an octopus with a lot of tentacles hanging. So for this particular case, we actually design a special shell for your needs. So you don't need to stay to the standard shell. Even in small quantities, we can just design a shell that is ready to go for you. You can tamper seal the shell, you can put labels on top, and you name it. 39 to 42 is okay for you? Perfect. Yes. Then you need to give me another shoe size. Yes, no problem. Any other questions on this, right? Do we have time still? Okay, then I have a question if there's no more questions. Do you think it's useful what I'm presenting here? Do you agree that what I'm saying here might be probably a good idea for you or not? And I'm happy to listen to different opinions here. You don't need to confirm what I'm saying. If you think it's not really relevant, I want to have a conversation on that. All right? Yes, please.
You talked about different, or the focus of your talk was freezing systems. But what about thawing systems? Is this something that you also have on your portfolio?
Yes.
We have some processes in which we receive kind of several hundred liters of biological materials, which is thawed in an uncontrolled way, maybe crushing and all this stuff. This is also something you can...
Oh, yes, absolutely. You don't even need a second equipment. All of these equipment are doing both, freezing and thawing. So you can use the same unit and have a recipe for freezing drug substance you have in your facility, and then the next batch comes and you need to thaw drug substance for down processing or for fill and finish. You can use exactly the same machine. We also have had customers or customer working with CMOs that they have one of these machines in the US, and then they have the same machine in Visp or in Korea, and they use it for thawing the material that was actually shipped between the US and the CMO. So that also happens, that we have two of these machines in two different locations. One machine is used for freezing, the other one is used for thawing. And it's exactly the same machine. You don't need to change anything. Thank you, good question. Cool, that's all. Then thank you very much.
No, thank you very much.